After we have learned how to do the multiplication and division of rational expressions, what we are going to do next, we are going to work on the addition and subtraction of the rational expressions. Those two operations are very, very similar. If we know one of them, we should be able to do the other one. So let's see. If we want to do the addition or subtraction of the rational expressions, let's do one thing first. What is that? Try to look for the LCD, which is called the least common denominator. First, for example, what I want to add or subtract those two. So 4x over x squared plus 2x minus 8. And I'm adding 3x over x squared plus x minus 12. See, this is a typical problem we might see in section 7.3. How can we add those two rational expressions? We cannot do this now. And what do we need to do first? We need to look for their least common denominator. So now let's see, how can we find the LCD? The least, their multiple denominator, they're not the same. So we are looking for their least common denominator. The least common denominator is actually their least common multiple. The least common multiple is what? C means common, M means multiple, L means least. Let's start with two numbers. So what do I have here? I have a number 6 and 8. Let's get a quick introduction to the least common multiple is. So there are two numbers. What is their least common multiple? Let's see, number 6. Let us list all of its multiples. The multiple of a number means what? Means multiply this number by 1. That's 6. By 2, we got 12. By 3, we got 18. By 4, we got 24. And then by 5, got 30, and so on. So 6, 12, 18, 24, 30, 36, 42, and so on. All those numbers, they are multiple of 6. Now let me write down the number 8. The number 8 has multiples of 8 times 1, that's 8, times 2, 16, times 3, 24, times 4, 32, times 5, 40, and then, okay, and so on here. And let's see what we have here. So all those numbers are multiple of 6. The second row are all the multiples of 8. If we continue, we'll see many, there are unlimited number of multiples for both of them. Then we'll see, are there any same numbers? Common means the same. What I see 24 and 24 here. If I continue actually, so I will see 48 here. Here I have a 36, 42, and then 48, and so on. So I will see another pair of same number, 48. If we keep going, we'll see 72 here as well. So there are multiple common, there are a lot, multiple common multiples. Okay, that's pretty weird to see in this way. So we'll see, but the smallest one, the least one is what? Is 24. So 24 is called the least common multiple of number 6 and 8. Okay, so this is the introduction of the concept. But apparently when we're working on the real numbers, the real problem, the big numbers, we do not want to list all the multiples. Why? Because it takes time. That's too time consuming. Now let's go back to the question, how can we find the least common multiple for the polynomials that include numbers. So I will introduce the method like this. So for whatever we're given, they can be numbers only. Let's look at here. I will factor each number completely. So 6 equals 2 times 3. That's the factorization of 6. What is 8? 8 equals 2 times 2 times 2, which can also be written as 2 to the third. So step 1, factor the two numbers respectively. Step 2, now we are able to write down their least common multiple equals what? So I will use every factor with their maximum exponents. So what does that mean? That means, so look at the first number. 2 is a factor. So I will use 2. So 2 is factor. In the first number, 2 has the exponent of 1. Then I move on to second number here. Does the second number have a factor of 2? The answer is yes. I see 2 here as well. Then 2, I will use the largest, the maximum times 2 appears once here. And the second number, 2 appears 3 times. I will use the maximum time that this factor appear in each factorization. And 3 is the maximum time. 3 is also the exponent. So 2, I will use 2 to the third. Or you write this as 2 times 2 times 2. It's up to you. Those two are the same. So I will use every factor. For now, I only use the number 2. Then move on. I see another factor, 3. Okay, so this is the factor 3 here. So 3 will be used. Now let's see how many 3s does the first number have? 3 appears once. Check the second number. How many 3s appear here? There is no number. So this 3 does not count. Just look at this factorization. There is no 3 at all. So 1 time and 0 time. What is the maximum time? 1 is greater than 0. So 1 time is for the number 3. So 3 should appear with the maximum times once here. Let's continue. So there is no more new factors. Move on to the second factorization. There is no more. So 2 have been used already. Done. I have used all the factors. Then just continue to multiply this product out. 2 to the third, that's 8. 8 times 3, 24. See, it matches the answer we list here. This is the straightforward but time-consuming way to look for the least common multiple. Here we have a 2-step approach to look for the least common multiple for any 2 numbers. Okay, and now the problem is, of course, we do not work with numbers all the time. And we'll see some polynomials. Let's start with monomial. Monomial is just one-term polynomial. So what I have here, I have 6x squared and 8x to the third, y to the fourth. So I have 2 monomials now. What I want to have, I want to look for their least common multiple for those 2 monomials. How do I look for this? So for all polynomial or monomial, we do the same thing. Let's see, I start factor each polynomial. Now this monomial, the only thing we can factor is the 2 numbers we have done before. So for 6 and 8, and we can factor them as, so 2 times 3, and then keep the x here. For 8 equals 2 times 2 times 2 times 2, and then x to the third, y to the fourth. So same thing as we did before. For monomial, the only thing we need to factor is their coefficient. Then we are ready to write down their least common multiple. Follow the same way as we did before. I go through the entire number and use every single factor, the maximum times they appear in each factorization. Okay, so 2 is one factor. 2 appear once here, 2 appear 3 times. So 2 will appear 3 times in their LCM. Then move on, the second number I see, a second factor I see is 3. 3 appears once, no 3 here, so 3 only appear once. Then I move on to the letters. So x is one variable. I'll say x squared means x appears twice. Then the second monomial here, I have x to the third. X to the third means x appears 3 times, x times another x. So for the common variable here, what do we always use their maximum exponent, 2 and 3. Which one has a bigger exponent? The second one, 3 is the largest exponent. Then we'll move on. So for the first one, there is no more new factors. We have to go check the second one. I have used 2 already. I have used x already. Y I haven't used yet. So y will also show up in their LCM. And there is no y here. I just used, so no y means y appears 0 times. Here, y to the 4th means y shows up the 4th time. So of course, 4th is a bigger number. I will keep this down. So y to the 4th. All right, so here, now carry out, this is after what we did in the first step here. 24 is the LCM for their coefficient. For every variable, I will just use their maximum exponent. Then we are all set. The LCM for monomials, we'll look for the LCM of their coefficients. And then for the variable part, we'll use every variable with the largest exponent. 2, 3, we use 3. This y, there is no y, I use the 4. Done. This is the LCM of monomials. Then let's see, how do we look for polynomials? For example, I have 2 polynomials on the top right here. I have copied them down. X squared plus 2x minus 8. This is the one polynomial. I have another polynomial, x squared plus x minus 12. To look for the LCM of polynomials, we do the same thing as we did on the numbers. Step 1, factor each one of them. How do we factor this trinomial? Leading coefficient is 1, and product of the two numbers should be -8, sum should be 2. So we know 2 times 4, that's 8. One of them has to be negative. If their sum is +2, then 4 should be positive. So to factor this, I get -2 and +4 are the two numbers that we are looking for. Product is -8, sum is +2. Second one, same thing. Leading coefficient is 1. We only need 2 numbers. What 2 numbers? Product is -12, sum is 1. 3 and 4. So 3 and 4 can get a 1. Then one of them should be negative because their sum is positive. So I know 3 should be negative. -3 and +4 are the 2 numbers we will be using in the 2 binomials. So step 1, factor those 2 polynomials respectively. Now let's move on. Write down their least common multiple. What is that? I will use every factor. So x minus 2 is one factor. So each parenthesis is one factor because they all have parenthesis times parenthesis. So x minus 2, write this down here. Then I will check how many times does x minus 2 appear in each factorization. The first one, I have 1. The second one, no. So the ones will be the maximum times. I will only use x minus 2 once. Move on to the second factor. I have x plus 4. So write down x plus 4. Then we'll look at how many times does x plus 4 appear in each factorization. So apparently we see x plus 4 here. I also see another x plus 4. So then what is the maximum times this x plus 4 appear? That is once. So it appears once here. It also appears once. So once and once. Which one has more time? They're equivalent. So the maximum is still once. Alert. Please remember, do not add the total times. So we are not counting totally how many times does x plus 4 appear. We are actually looking at in every factorization, in every product here, how many times does this factor appear? Then we use the maximum time. So once and once, the maximum time is still once. I will only use one x plus 4. Then keep going here. So I use this one, I use this one. Then in the second polynomial, I see a new factor, x minus 3. So again, x minus 3 appears once here, 0 times on the top. So once, one time is the maximum time. Then keep going. I see x plus 4. X plus 4 is not new anymore. I have used this already. Then forget about this one. What we have here, this product is the least common multiple of those two polynomials. And now let's look at back. When we are looking for the least common multiples, we start with the easiest case, the numbers only. What do? Factor each number completely, and then use every factor, the maximum time they appear in each factorization. When we have a monomial, which means not only we have the number, we have variables as well. What do? Look for the least common multiple for their coefficient first, using the way we did before. Then for every single variable, we always choose the largest exponent, 2 and 3. 3 is bigger. Why? There is no y here, so then we use y to the 4th. If we have a polynomial, then we have to factor each polynomial respectively, then follow the same way. We will be using every factor the maximum times they appear in each factorization. So do not use the total times. We'll use so individually in each factorization. We count how many times that this factor appear. Okay, so those are the preparation. How do we look for the LCD? Now, let's start to work on the addition subtraction. So to add or subtract the two rational expressions, when they have the same or common denominators, things is very easy. It's same thing as, for example, if I'm adding 1/6 plus plus 1 plus 5, 6. What we are adding? We are adding two special rational expressions, as I told you before. The fraction number, they are also rational expressions. How do we add those two fractions? We are going to keep the common denominator. 6, 6, still 6. We'll add the two numerators, 1 plus 5. So keep the common denominator. We add the two denominators. Then simplify the denominator and numerator respectively. So numerator plus numerator, 1 plus 5, 6. 6 over 6. Can we leave this answer here? The answer is no. We have to simplify all rational expressions if possible. So 6 over 6, that's 1. The final answer is 1. This is the fraction number. If we have a regular rational expression, follow the same way. So look at what I have here. I'm doing a subtraction. So, okay, let's look at their denominator. Do they have the same denominator? I see x plus 5, I see x plus 5. Okay, they are ready to be subtracted now. keep the common denominator, which is still x plus 5. And then what do we do? Just subtract the numerators, because this is subtraction. If I'm adding, then I add the numerators. And if I subtract the numerators. 4 subtract 6. Then continue to simplify. The numerator turns into 4 minus 6, that's -2. And then I have x plus 5 here. There is a very typical question. So you might be asked, Professor, how can I leave the negative sign on the top, or should I move it? So the answer is, you can leave this on the top, or you can move. So if there is one negative sign on the numerator or on the denominator, you can always drag it out in front of the entire rational expression. The denominator remains the same. So those two answers, they are equivalent. You can also leave the negative sign in front of the entire rational expression, or you leave the negative sign on the top. They're equivalent. So this subtraction here, when we have the common denominator, the calculation is easy. But I want to remind you, especially when we are working on subtractions, we have to be very careful with the subtraction here. Okay, this is one problem I want to show you. What we are doing, this is the opposite. We are subtracting two rational expressions. Now, when we look at this, we see, oh, those two rational expressions, they have the same denominator. So which means we are ready. So to subtract two rational expressions, when they have the same denominator, we'll keep the denominator. 4x plus 1 is on the bottom. And then we use the numerator 1, which is x minus 7. Subtract. The second numerator, 9x minus 5. Okay, so what I want to show you here, did I get the right way to write down the subtraction? The answer is no. If I write the operation in this way, I will get a totally wrong answer. Why? Because the entire 9x minus 5, they should be stay in a parenthesis, because altogether, that is my numerator 2. And this is my numerator 1. So whatever I have, I will use numerator 1, subtract numerator 2. The first parenthesis really does not matter if you keep it or does not keep it, because we can just simply remove it. But it is very, very important to keep the second parenthesis for this numerator. Why? Because there is one minus sign before the parenthesis. We know when we remove the parenthesis, we have to change the sign, use the distributive law. So if I continue to do this one here, the problem actually turns into 4x plus 1. I have x minus 7, remove the first parenthesis. When I remove the second parenthesis, distributive law should be used. Minus 9x minus -5 turns into plus 5. Okay, so if you do not have this minus sign, as I did at the beginning here, you will have a -5 here. That is totally wrong. So this is one thing I really, really want to remind you. When you do the addition, there is no such concerns. You just put the numerator 1 plus numerator 2. You really don't have to keep the parentheses. But when you are doing the subtraction, it is very important to keep a parenthesis around the second numerator. Okay, then you have to remove the parentheses by applying the distributive law. In some terms, okay, not every term inside of it should change the sign. So 9x turns into minus 9x. -5 turns into plus 5. Then you can continue, just combine like terms. What I have here, x minus 9x, negative 8x. Negative 7 plus 5, negative 2, over 4x plus 1. Okay, so when we got here, we want to ask ourselves, should we stop here or can we actually continue? So for all fractions or for all rational expressions, we have to make sure they are simplified. It's the same thing as the first problem I showed you. When you get 6 over 6, you cannot leave 6 over 6 there. You have to simplify it to 1. Same thing here. Now we go back to section 7.1. When we are given a rational expression, can we simplify it? How can we simplify a rational expression? We are going to look at the numerator and denominator respectively. See, can we factor the numerator? Negative 8, negative 2. I did see a common factor too, negative 2. So I will factor the GCF out. Negative 2, what is in the parentheses? Negative 8x divided by negative 2, that's 4x. Negative 2 divided by negative 2, that's 1. So the leftover goes into the parentheses. What the leftover? The quotient. So divide every term by the GCF. Then we'll have a parenthesis here. Over what? Over 4x plus 1. The denominator cannot be factored. If it cannot be factored, then it will stay as one thing. After we do this, we'll see there is a common factor between the numerator and denominator. 4x plus 1, 4x plus 1, those two factors, they cancel each other. Then what is left? Negative 2 on the top. If there is nothing left on the denominator, we just ignore it. That means over 1. Everything divided by 1 equals itself. So it ends up with negative 2. Final answer. This is a very, very typical subtraction problem. The only thing I want to remind you is what is make sure you keep the parentheses for the second numerator. Then when you remove the parentheses after the minus sign, pay attention to the term signs, change the signs. Okay, so this is the first type of addition subtraction when they have the same denominators. We just keep the common denominator. Now the problem turns in what if they do not have the same denominators? What do we do? And what I do here, let me look at one problem. Okay, one problem, simple problem as this. This one. They're not very simple. Let me start with the simpler one. Okay. Where can I find a simpler one? Let me grab a piece of paper. Okay, so what if I have this problem? I'm going to do this. So 5 over 6x plus 3 over 8x squared. Okay, what I'm doing now, I'm adding those two rational expressions. When I'm given the problem, step 1, I will check, do I have the same denominators? Apparently, those two denominators are not the same. Then on my scrap paper, I will write down those two denominators. The first one is 6x. The second one is 8x squared. Then what I do, I will try to look for the least common multiple of those two denominators, which will be called the least common denominator. How do we do this? We have done this before. So step 1, we'll look at the least common multiple for the two coefficients, 6 and 8. So remember, we have to do 6 is 2 times 3, and then times x. 8 is 2 to the third, then times x squared. So still, you try to factor the coefficient respectively. Then write down the least common denominator or least common multiple. They mean the same thing here. Is what? Is I will use every factor. 2 here, 2 to the third. This is the third time we are working on this problem. 3, there is no 3, I use 1, 3. Then for the x here, every variable, I will use the largest exponent. There is no exponent, means that's 1. That's 2. The large number is 2. Then continue to simplify this. That's 24x squared. So now I know for those two different denominators, their least common multiple should be 24x squared. Now I will go back here. So to add those two rational expressions, I really want they have the same denominator. Since they're not the same for now, let's turn them into the same denominator. What will them be turning to? They will be turning to their least common multiple or the least common denominator here. So write down the original rational expression, then compare the original denominator with their LCM. See, what factor do I have to multiply? Then I will get the LCM. Or another one, if I divide the LCM by the 6, by the original denominator, what the quotient should be. So this is what we call, or you see, compare those two. So this is the original one. This is the LCM. Compare those two. What is missing here, we have to make this up. See, I have 1 2, but this one has 3 2's. So 2 2's is missing here. I have 2 to the second. I have 3 here. This one has 3, so 3 is okay. I have 1x. This one has x squared. What is missing here? 1x is missing. So actually 4x is missing. Or you see, I really don't like this, professor. So is there any other way to look for what should be multiplied here? Do the division. You see 24x squared divided by 6x. What the quotient is? 24 divided by 6, that's 4. X squared divided by x, that's x. So 4x should be multiplied here. So you either write down this 2 squared x or 4x. It's the same thing. Then just remember, whatever you do to the denominator, always do the same thing to the numerator. So the numerator should also multiply 4x. So you can write this 2 squared x or 4x. They're equivalent. Add. Then copy the second term down. Take your time. Then do the same thing. How can I turn 8x squared into 24x squared? So how can I turn this one into this? What is missing? This one the same. There is only a 3 missing here. So times 3, this denominator will turn into its LCM. If I multiply 3 on the denominator, do the same thing to the top. The numerator also times 3. So what we have now we'll have multiply those two. I will have, so this will be 20x squared, and numerator is 20x. And then plus 24x squared, 3 times 3, that's 9. Now I have a new problem. I'm adding 2 rational expressions. They have the same denominators. Then I will keep the common denominator, 24x squared. I add the 2 numerators, 20x plus 9. Finally, I will check, can I continue to simplify this rational expression? The answer is no. Then we'll stop here. Final answer. So to add or subtract 2 rational expressions, when they do not have the same denominators, we have to look for their least common denominator. They can be pure numbers. They can be monomials. They could be polynomials. I'll show you another example. So whatever we have here, Just look for their least common multiple and then turn the old denominator into their least common multiple by making up some missing terms or by multiplying something. What do we multiply? Divide the LCM by the original denominator, the quotient, or compare those two. Whatever is missing here, we make them up. There are multiple ways to do this. Okay, whatever you choose, just follow your way and multiply both the numerator and denominator by the same thing. Then those two terms will have the same denominator. We'll continue to add or subtract them. One more example now. So now let's go back here. What if I have a problem like this, 15? So given what? This is one addition problem. Those two does not have the same denominator. So step one, you can keep this down. Step one, I will factor each denominator respectively. The first one, q over what? Q squared minus 2q minus 3. We can factor this as q plus 1 times q minus 3. And then plus 3 over q minus 3. So step one, you can write down the factored denominator. Then step two, you move on to your square paper. So I have two denominators. First one is q plus 1 times q minus 3. This is the first denominator. The second one is just q minus 3. Then what is their least common multiple or least common denominator? Since they have been factored already, and the only thing left right here, we'll just use every factor the maximum time they appear in each factorization. So q minus plus 1 used once on the top. The first one, there is no, and the second one is the once is maximum time. Q minus 3 appears once in the first, appears once in the second. The maximum is still once. So Q minus 3 is also used once in their least common multiple. There is no more new factors. So this is just one factor here. I'm done. I have found the least common multiple, or the least common denominator is q plus 1 times q minus 3. Then let's move on. Go back to the problem. Do I have to change the first one? The first one has been the least common multiple already. So it stays the same. Q over q plus 1 times q minus 3. Then the second one, I had q minus 3 only on the denominator. Comparing this one with the least common denominator, q plus 1 is missing. Then I make this up, multiply q plus 1. Whatever I do to the denominator, do the same thing to the numerator. This one also times q plus 1. The red pen is the thing I have changed. I turned the old denominator into the new denominator, which is their least common denominator. Then what I do, I can add now because those two, they are same. So pay attention to the order does not matter when we do the multiplication, this commutative law. The least common multiple will be their common denominator. So the denominator remains the same. I add the two numerators to q plus 3 times q plus 1. And then you are going to do what? Simplify the numerator only. Remove the parentheses. Q plus 3q plus 3. Distributive law over q plus 1, q minus 3. Then combine like terms. 1q plus 3q, that's 4q. So 4q plus 3 over what? What's wrong with my okay. My document camera. Oh, power. I have a power off here. I'm sorry. Okay, so my house lost the power. That's why my okay. Yeah, I lost my internet as well. It's too windy today. So let me see. Yeah, just continue and finish the problem. Let me see. Okay. Are you able to